In this episode of ESPN Sports Science, we're going to take a closer look at the physics of archery. Here, we have Brady Ellison against Ojin Hayek from Korea.
Brady Ellison is up next to shoot. They are currently standing 7 meters from the target.
During his shot, we decided to time to see how long it got from his hand to the board, and we got 2.9 seconds. Okay, so if you look closely on the board, the arrow speed is 203 kilometers per hour, which would be your average velocity.
Okay. Using information from Target 1, we decided to convert kilometers per hour to meters per second. So it started off with 203 kilometers per hour, and in order to get hours to seconds, you have to cancel out the hours, which is 1 hour over 3,600 seconds. And then to cancel out the kilometers to meters, you have to multiply 1,000 over 1, and that gives you the 56.4 meters per second.
The next target we decided to use was target 8, which we are going to find the final velocity and the acceleration. Knowing that it took a relatively 2.92 seconds to get from his hand to the target, and the average velocity of 56.4 meters per second after we have converted it, delta x would be 70 meters since that's the distance he was from the target. The VI, or initial velocity, would be 0 meters per second as it was out of his hand. So here we are going to find the final velocity and the acceleration for target 8. In order to find the acceleration, we first had to find the final velocity. So we use the equation VAV equals VI plus VF over 2. So then we just plugged in our variables from the last part. The variable for the VAV would be 56.4 meters per second. The initial velocity was 0, and we do not know the final velocity yet. So here we just multiply each side by 2, and we would get the final velocity of 112.8. Now that we have the final velocity, we can find the acceleration. We would use the formula VF squared equals VI squared plus 2A delta x. We would plug in the 112.8 as the VF, the 0 as VI, and the 70 as delta x. After combining the 2 and 70, you would get 140A, and doing the 112.8 meters squared, you'd get 12,723.84. So then you would divide both sides by 140 to get the acceleration of 90.9 meters per second squared.
To conclude, Brady's arrow really do fly. Archery isn't just about hitting an arrow to a board. It's physics.